Good morning, students. So in the last class, we discussed about some of the important, very important reactions of aldehydes and ketones in the repetition class. So in today, we are going to discuss about only the reactions of that carboxylic acids, the very important. So students, as I told you, the carboxylic acid reactions are only some small reactions are there and only little bit reactions are there, not like that aldehydes and ketones. Okay, so that esterification is there, reaction with PCl5, PCl3, SO2 is there, domination is there, nitration is there, HVZ reaction is there. Along with that, I'll explain the acidity of the compounds. Okay, so students, from this we are going to study the first reaction of the carboxylic acid, that is esterification. Okay, so actually this is 16th reaction of this book, carboxylic acid and aldehydes, ketones and carboxylic acids. Esterification reaction. So what is this esterification? The formation of esters. From what? From carboxylic acid and alcohol. And right here, example of carboxylic acid, C double bond to OH. What it is? Carboxylic acid. So this carboxylic acid made to react with alcohol in presence of concentrated H2SO4. So students, wherever we use concentrated H2SO4, the thing we need to remember is what? Elimination of water. Okay, then here is R, C double bond O, R. This is what? Ester. Water molecule is removed, ester will form. Okay, so here plus H2. Okay, so this one is what ester. Carboxylic acid reacts with alcohol in presence of concentrated H2SO4 forms ester. Okay, and here carboxylic acid reacts with alcohol in presence of concentrated H2SO4. In bracket you take dehydrating agent. Forms yes. Okay. So example, in the place of that you take ethanoic acid plus methanol. When they made to react in presence of concentrated H2SO4. But I said water molecule is removed from the acid as well as alcohol. Then the product formed is CH3, C double bond O, CH3. Methyl ethanoate, that is ester. Plus H2. Now the explanation. So in the place of carboxylic acid, just replace ethanoic acid. In the place of alcohol, methanol. In the place of ester, methyl ethanoate. Okay. Next here, ethanoic acid reacts with methanol in presence of concentrated H2SO4 gives methyl ethylate. Okay, next you take example 2. So in this example you take benzene. What is the name of the compound? Benzoic acid. Made to react with, I'll take methanol only. In presence of concentrated H2SO4 gives what? Gives, so this R is a benzene ring with C double bond OCH3. Here also H2O is removed. So students here, this is methyl benzoate plus, so this is the reaction. So how can I write the explanation here? Remember, and just remove this to write the explanation. I will write the explanation just above. So follow this. The place of carboxylic acid, take benzoic acid. Reacts with, in the place of alcohol, methanol. Benzoic acid reacts with methanol in presence of concentrated H2SO4 gives the methyl benzoate, that is an ester. Understand? So students, this is about the esterification reaction, important for 2 marks. Remember, this esterification reaction is also studied in the alcohols and also is studied in the carboxylic acids. In both the cases, alcohols, phenols, this one is the phenol, of course we studied. Alcohols, phenols and the carboxylic acid, all these show this esterification reaction. The thing is same. Acid react with alcohol in presence of concentrated H2SO4 gives an ester. Okay? This is one reaction. So the next one is reaction with PCl5, POCl3 and SOCl2. So students, that is 17 reaction with PCl3, PCl5 and SOCl2. First one you take carboxylic acid with TCl3. Remember students, wherever you use TCl3, just three times of the molecule. No matter this is in alcohol only or any other. Wherever PCl3 is there, the reactant is requires in 3 moles. Okay, so 3 moles of this. Okay, so here it is R C double bond O Cl removes plus H3PO3. Okay, R C double bond O, complete OH removes 3 times, O 3 times, H 3 times. This Cl is attached here, this P, so H3PO3. Understood? So next, so if instead of this, if you take PCl5, okay, so in this PCl5, the reagent is, of course, no doubt, RCl plus POCl3 plus HCl. Always, wherever PCl5 is there, this must be the byproduct, POCl3. And next, if in case you take RC double bond OH in presence of SOCl2, then you get RC double bond O Cl plus SO2 plus HCl. Both are gases, the escapes. Okay, so students, among these three, I'm not writing any explanation here because they won't ask explanation. They'll just give reagent, so reactant, and the product they will give, they'll ask the reagent. Understood? So this is the way they are going to ask the product and the reactant. And remember the reagents. So complete the reaction type questions they are going to ask. So I am not at all writing any explanation here, but I write example. Example 1 for all these. So I will take ethanoic acid as an example. So if this ethanoic acid is there, assume. So here the product form is CH3 C double bond OCl plus H3PO3. Now, it is not a balanced reaction. They give reactant and the products. So from this reaction, we need to know. So H3PO3 is there, means we need to take PCl3 as an example. Here, we need to know this. Okay, so ethanoic acid. Now, here writing the name is very important. Here I didn't write. Okay, these are all carboxylic acids. Ethanoic acid. This is phosphorus trichloride. This one is acyl chloride or acetyl chloride. This is phosphoric acid. You get complete marks. Okay, next. CH3 C double bond OH plus PCl5. So this is ethanoic acid product. This is phosphorus pentachloride gives CH3 C double bond Cl, that is acyl chloride plus POCl3 phosphorus oxychloride, phosphorus oxy trichloride, not chloride, trichloride. Plus HCl. No need to write HCl. It's the last one. CH3 C double bond OH. Of course, ethanoic acid reacts with SOCl2, that is thionine chloride. Thionyl chloride gives CH3 C double bond O Cl, that is acyl chloride, plus SO2 plus HCl. So students, among those things, this is the best way of preparation of acyl tablets from the carboxylic acid. What is the reason? Because the byproducts formed here both are gases and they easily escapes. The product formed here is 100% pure. So this is the best method for the preparation of acyl chlorides from these acids. Okay, so in the place of this acetic acid, you may take benzoic acid also. Means this CH3R group you may replace by benzoic acid, then benzoyl chloride will be the product. So I'll write it also. Okay, so listen, if this R group, that is example 2, if R group is replaced by benzene ring, so R, that is benzoic acid, reacts with phosphorus trifluoride. No doubt this is 3 moles, gives 3 moles of benzoyl chloride. Suitable part group Cl plus H3PO3. So students, this one is benzoyl chloride. Okay, this is benzoic acid. Next, similarly, take the benzoic acid. If it is react with BCl5, no doubt it form benzoyl chloride plus POCl3 plus HCl. Byproducts are always same, only the thing changes here is what? R group. Next, third one. Benzoic acid plus SOCl2 gives rise to SOCl2 means it is thionyl chloride, benzoyl chloride plus SO2 plus HCl. Okay, so this is all about reaction of this benzoic acid with PCl3, PCl5, SOCl. Note, wherever PCl3 is there, we need to take 3 moles of the respective reagent. Wherever PCl5 is there, we need to take, so the byproduct formed here is POCl3 and this entire SO2 and HCl are the byproducts. The very easy reactions. It is common for all. Okay. So the next one is domination and nitration. Before explaining the domination and nitration, we need to check which products are more major. Okay, ortho, meta, or para. So students, I'll take the benzene ring here. To this benzene ring, carboxylic acid is there. Okay, so remember, OH is there, oxygen. So this is also electron withdrawing OH minus, and at the same time here double bond is there. So students, if the lone pair electrons are like this, then what happens in the resonance? These electron shifts here, these electron shifts here. Then at the same time, these electron shifts here to increase electron density. Then, so this is the benzene ring. Okay, I take double bond here. single bond, C single bond O. Here this type of electron with the minus charge. Here plus will come. So here the electrons are displaced here. This is OH. Then here positive charge because these electrons are shifting here. Means this carbon like this. So this is one electron of this carbon, one electron of this carbon. They form bond. This is completely transferred here. Means this carbon atom is leaving this electron, means getting plus charge. Similarly, in the resonance, if we write, so this shifts here, then here the bond will form, here the bond will form, here the positive charge. So double bond C OH, oxygen with the minus charge. Similarly, if these shifts here, then the benzene ring, here bond will form, here bond will form, here the positive charge, double bond C, oxygen atom, OH. Sorry. OH. Okay. Now, so these electrons again shifts here, again shifts here. Then we will get the equivalent structure. Like bonds are formed in the alternate position C double bond OH. So students here at this ortho position and the para position. These two are the ortho. This one is the para position. Positive charge is there. If the nitration takes place or bromination takes place, in the nitration we are going to get NO2 plus. In the bromination we are going to get Br plus. Both are electrophiles. So here it's a positive charge, here also positive charge, means they are not able to bond there. Means in ortho and para position, nitration and bromination cannot take place. Means electrophilic substitution cannot take place. Then what happens? Only if here plus is there, this must be the minus charge. These two are the minus positions. Here plus is there, this must be minus. Like that. Means, so this is not like minus. This is simply we are going to consider here at the ortho and para position electron density is less, they are getting positive charge. So they are exhibiting positive charge, means there is no possibility of electrophilic addition at that position. So that's why the meta position means having high electron density. Understand? So this is COOH is an electron withdrawal. If nitration takes place or bromination takes place, so the meta product will be the major product because the COOH group is a meta directing group. Understand? Okay. Now you take benzoic acid. Okay, you take benzoic acid. So when the nitration takes place, I write first one is nitration. Consider this benzoic acid or benzoic acid. Undergoes nitration. So wherever the nitration we are going to say, the reagent is concentrated HNO3 and concentrated H2SO4 both. Here this is the benzoic acid, means COOH you take completely. COOH means with respect to this here oxygen atom is bonded. This is here COOH is bonded. With respect to this, these two are the ortho position. This one is the meta position. Okay, that means here the NO2 is meta nitro. Meta is written like this. Beta-nitro benzoic acid is the major. Next, second one, bromination. So students, if the bromination takes place, okay, bromination in presence FeBr3 as a catalyst. Okay. FeBr3, then we are getting that is meta bromo benzoic acid. Meta-bromo benzoic acid. This is benzoic. So students, almost there are directly it's like bromination of this nitration of benzoic acid, bromination of benzoic acid, like that. So here these are important for 2 marks. And the last one reaction is there, that is HBZ reaction means L-Zelinsky reaction. Okay, so what is this reaction? Especially this is reaction of acetic acid. So acetic acid undergoes chlorination in presence of lead plumber. Okay, therefore chloro substituted acetic acid. So that is plus H. This one is you take ethanoic acid instead of acetic acid. Ethanoic acid. This is 2-chloro ethanoic acid. This is also important for chemicals. So this completes what? The reactions of the carboxylic acid. Esterification, reaction with KOCl3, ECl5, and another one is what? SOCl2. This is nitration, bromination, and HBZ reaction. So students, another one is there, that is soda-lime reaction. Remember that is soda-lime reaction. I forgot to tell you, important word. So this carboxylic acids react with soda-lime means this one. CaO. NaOH is called as soda-lime. Okay, and CaOH is called as caustic soda. Okay, so remember this carboxylic acids reacts with this NaOH in presence of CaO. They form moles RH plus Na2CO3. RH plus Na2CO3. They form what? Hydrocarbon. Okay, so this is what? Soda-lime reaction. So in the place of this, you will take C double bond OH plus 2KOH. In presence of CaO, you take CH4 plus Na2CO3 plus H2O. This is what? Soda-lime reaction. So this is about the reactions of carboxylic acids. Okay. So now the important thing is acidity of or acidic character of this carboxylic acid. You know, the carboxylic acids are the most pure functional group. Priority is mainly given to this carboxylic acid. This is the pure group over all the functional group. It may be CH3, it may be any alcoholic group, phenolic group, amine group, anything. The most pure one is this carboxylic acid. So in this, what happens to the acidic character and in the presence of electron withdrawing group and electron releasing. So listen. As in their acid, the acidity is measured in pH. Okay, so if pH is equal to 7, neutral. So pH is less than 7, acidic. So pH is less than 1, more acidic. pH is greater than 7, basic. pH is greater than 14, more basic. Okay? So this is the pH range. So what happens to this pH range when the electron withdrawing group is there and the electron releasing group is there? So I'll consider electron withdrawing groups. So remember here students, what are electron withdrawing group? All nucleophiles. All nucleophiles and double bonded atoms are the electron withdrawing groups. For example, OH minus, Cl minus, F minus, and H2 minus. Okay, and OCH3 minus. So all are what? Electron withdrawing nucleophiles, negatively charged species. And at the same time, the double bonded compounds means C double bond OH, C double bond O, C double bond OR, and C double bond OH. So this OH is not required. NH2. Okay, so this type of double bonded compounds or carbonyl compounds are electron withdrawing groups. Withdraw, remove. Okay, so if this type of groups are there, then what happens? So if electron withdrawing groups are there, acidic character increases. Why? Why? Because listen, this is the benzoic acid. I assume this is COOH. Okay, so along with this, not COOH, initially you take instead of COOH acetic acid. CH3 COOH is there. Assume instead of H3 here, CH2 Cl is there. So this Cl, if it dissociates as CH2 plus and COOH, and here it is Cl minus. Then it causes plus charge here. Electron density is less. Electron density less means here plus charge generates means then it requires electrons. So one which accept pair of electron, that is Lewis acid. One which donate pair of electron, that is Lewis base. So these become Lewis acids. Means, so if the electron withdrawing groups are there, then the acidic character increases. Because that decreases the electron density. Decrease in electron density made in resulting accepting an electron. The accepting an electron means, according to Lewis concept, it is a Lewis acid. Okay, means the acidic character increases. Assume instead of one, if two or more are there, means the CH, Cl, Cl, COOH means CH, sorry, C, Cl, 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 more number of electron withdrawing group increases acidic character. First one. Next, you take CH3, CH2, COOH. Next, CH2, Cl, CH2, COOH. Next, CH3, CH, Cl, COOH. So students, here there is no electron withdrawing group, so this is less acidic. Here, compare these two. So here COOH group is there, here COOH group is there. This Cl atom is far away from, so this Cl atom is nearer to this COOH group, but this Cl atom is somewhat far away from this COOH group. Means here closure the electron withdrawing group to carboxylic acid group, greater is the acidic character. Greater is the acidic character. More number of electron withdrawing group means more acidic character. If the electron withdrawing group is closer to COOH group, then also it is having greater acidic character. So if second one is electron releasing group. Electron releasing groups are only alkyl groups. So remember students, if the alkyl groups are there, here I am telling, two alkyl groups are there. This is an electron releasing group. It releases electron towards this. Electron density increases. Then this is an electron releasing group. It also donates increases electron density here. If the electron density is more, electrons are more, instead of giving accepting an electron, they prefer donating an electron. So according to the Lewis concept, one which donates the electron, it is a base, not an acid. Means if the electron releasing groups are there, the acidic character decreases. And remember here, if more number of electron withdrawing groups are there, like here 2 are there, 1, 3, 2, like that. If more number of electron releasing groups are there, not withdrawing, more number of alkyl groups, then acidity decreases. Understood? So this is all about acidic character of acetic acid. Now we will discuss benzoic acid. So in the benzoic acid also same. If electron withdrawing group is there, then acidity decreases. If electron releasing group is there, then acidity increases. Next here, if we take benzoic acid, so we are not involving carboxylic acid group here, COOH. So here assume NO2 group is there. So if NO2 group is there, it withdraws the electron towards itself. Okay, so means if it withdraws the electron towards itself at this carbon, electron density decreases. If electron density decreases, it requires electron to maintain the neutrality. So then it prefers accepting an electron, then acts as Lewis acid. So if the electron withdrawing groups are present on the carboxylic acid, they increases acidity. Next, second one, electron releasing group. So benzoic acetate. So this benzoic acid, that is COOH, here CH3 is there. Okay. So if CH3 is there, this is electron releasing. When it releases electron, the electron density is more at this carbon. Donate the electron, that is what Lewis phase. Similarly, as in the acetic acid and all, if the electron withdrawing decreases, electron releasing groups are there, acidity decreases. Understand? Both in aliphatic also, in aromatic also. Understand? So if more number of electron withdrawing group, acidity keep on increases. More number of alkyl groups, acidity keep on decreases. Understand? So students, this is about the reactions of carboxylic acid. So this completes the repetition of aldehydes, ketones and carboxylic acids. In the tomorrow's class, we will discuss with another one chapter, that is amines. Once the amines completed, I completely discuss about the classification and the nomenclature of the compounds, including all, not only one like amine, aldehyde, alkyl, like that. So including all, I will give you how to answer the questions. Okay? So, and in the tomorrow class, we will discuss with the important questions of amines. Thank you.